I am going to wait a second just to make sure that the stream has caught up before we go ahead and get started. Let's go ahead and switch over to our title screen. Okay, so I think we are all set to go. So we are going to go ahead and get started. So welcome to the second workshop of CodeLabs 2018. And this is going to be Introduction to Electronics. So again, kind of the basics, very basics of electronics. If you don't entirely know what you're doing, that's totally okay. You don't need to know what you're doing for this workshop because it is really the absolute basics of electronics. And I'm just going to go ahead and check to make sure that our stream is working. We're trying a hopefully more functional setup. It says we are offline, and then it says we're live. So Twitch, very interesting. So cool. I can hear myself too. So if anyone has any questions, feel free to post them in the live chat. I am keeping an eye on that as well, but we should be good to go. So we're going to talk about Introduction to Electronics. And again, the basis of this workshop is really just like trying to understand what is going on when you have a circuit board. We're going to talk a little bit about things like Arduino, which you might have heard of. Let's see if I have one here. I have a smaller Arduino than you might be used to if you've seen themselves. If you've seen these sort of things before. So Arduinos, some of the basic stuff like that, how you can program things and how you can actually make them do things that you want them to do your bidding. Everything, you can do everything from, for example, I have a system to automatically open and close my blinds so that when I wake up in the morning, it is unreasonably bright and there's no way I can possibly sleep in, to I have a system to automatically water my plants and keep track of the water level. These are all the sort of things that you could theoretically do with electronics once you learn the basics of how it actually works. So that's what we're gonna learn a little bit more about, how to do some of that basic stuff with something like an Arduino or similar. We're also going to learn a little bit about how something like an Arduino actually works and how any electronic device that you've ever seen, how you could theoretically create something like that. This is actually also a prequel, I guess, to the workshop that we're going to do on Friday, where we learn to design our own printed circuit board and actually get that ordered. And you'll actually receive in the mail something that looks like what you're used to seeing when you talk about circuit boards. So it should be really cool, a lot of fun, and we'll go ahead and get into it. So I'm going to go ahead and switch. I only have one camera, so I have to actually move the camera around. So hang on just a second. So do that. Okay, so this is the best that we're going to be able to get for today. Still working on the exact setup for how this whole streaming thing is going to go. But we are going to talk a little bit about some electronic stuff using paper as an example first. Then we will talk about, again, things like these Arduinos. Let's see. So we get some things like Arduinos. Let's go ahead and do this way. So we have things like the Arduinos. But before that, we're actually going to talk about some basic things like these, which are called breadboards. And you may have seen breadboards before. Hopefully you have, but if you haven't, that's okay. We'll get into that as well. Someone was asking in the chat, could this be used for a Raspberry Pi? Absolutely. And that's actually one of the advantages of a Raspberry Pi as well. The thing about an Arduino, the thing that's really nice about this is that it's a remarkably simple device. And it doesn't take much power, and it boots up immediately. But the disadvantage is that it's a little bit more difficult to program sometimes. So we'll talk about that as well. But before we talk about any of that, let's go ahead and get these out of the way. We are going to talk about the very basics of electronics. So we'll go ahead and put those away. So when we're talking about electronics, there are a few really basic pieces that you may have seen. This is probably one of the most visible ones. You might have seen something that looks like this. It's called a capacitor. And you may have also seen them. Let's see if I can find an example. This will be a little bit harder to see, but we'll make it work. You may have also seen them. They look a little bit tiny sometimes. They're really, really tiny looking things sometimes. So this is called a capacitor. And whenever we're talking about capacitors, we're going to draw this symbol. That's a capacitor. Whenever you see one of those, you can be sure that you know what it is. Second thing that we're going to talk about, let's see if I can find one of these, is called a resistor. So this is called a resistor. And you'll usually see them drawn like this, but sometimes you'll see them drawn like this as well. Don't worry about what any of these do yet. We will talk about that in a second. And sort of the last piece that you'll sometimes see, this is probably the least frequently seen, is called an inductor. And an inductor actually looks a lot like a resistor. You can't really tell in the way that this webcam is not focusing, but this is a slightly more, it's just a slightly different color. So inductor. Usually you'll see them around this size, but you can actually get much bigger ones. And I don't unfortunately have an example, but I do have an example of something that is effectively an inductor. An inductor is basically just a coil of wire. And so usually when you see an inductor, you'll see it drawn something like this, or like this, because it is effectively a coil of wire. So that is kind of what we are looking at as the three basic building blocks of any electronics project. There are some other things as well. There are some other things that you might see. So for example, you've probably seen something that looks a little bit like this. I know that you can't really see that down there, but it's one of these things. You know, it's a little black mysterious box that's got some leads coming out of it. More or less anything that looks like this is going to be what's called an integrated circuit. And there are other ways that these can look as well. They don't necessarily look exactly like this. But you might also see some things that look like this. And a bunch of other really complicated, sort of more advanced looking things. These are generally all using something called semiconductors. And one of the really cool things about this is that you really don't need to know much about semiconductors to get started, because semiconductors really came on to the electronics sort of market relatively recently. So it's a little bit more advanced, and we will probably start using some of them, particularly a thing called transistors, which you might have heard of, in some later workshops if we get around to it. But if you can understand these basic three things, that is probably all you really need to know. So we're going to start out by just talking a little bit about what these three things do, so that later on when we actually start making things, we can understand a little bit more, so that we really get what we're doing. These two, the inductors, we're actually not really going to use very much, so we're going to leave those out of this explanation for right now, and we're just going to focus on capacitors and resistors, because those are the two things you're probably going to need to know about. So a common explanation of how things work in electronics is actually water systems. So if you live in a town and you get some nice little happy buildings here. Someone was asking, is this going to be recorded? This will be recorded. And by the way, do make sure to check your email, because we did send out a schedule of all the workshops for this week. But this will be recorded. It'll be on YouTube. So, let's say you get this little town down here, right? Little town. and they all have some pipes going into them to give them water, right? And I don't know what happens at the end of it, but let's say that it just ends right there, right? So there's these two little houses over here. This one probably needs a door. And they have some water going into them. And when you look at things this way, what we start to think about is, okay, well, what do our capacitors do? And it actually turns out that capacitors do a lot of what they look like. They're kind of like little water towers. So what does a water tower do when you see one of those, the big, sometimes they're really big green buildings. Sometimes you'll see them where they look like, maybe like a cylinder with a pipe going down it and then like some girders. And I apologize, I'm not the world's best artist. But yeah, so happy trees. But sometimes you'll see it look like this, sometimes you'll see it look like this. You've probably seen something like this. They're water towers. What a water tower does is it kind of keeps pressure in a system, right? It makes sure that if a bunch of people are using water at the same time, that, for example, there's enough pressure, there's enough water sort of pushing its way up that maybe someone at the top of this apartment building can still get water, even if a bunch of other people are using water, right? Because the only way that this water is going to get up here is if there's enough pressure. Pressure, so again, water towers, right, keep pressure. Capacitors are kind of like water towers, and what they do is, one of the things that they can do a few things, but one of the things that's going to be most relevant for us is that they can keep voltage. Voltage is a lot like pressure. So voltage is kind of like pressure. What do I mean by that? Well, one of the really interesting things about voltage is that it can actually kind of exist even if there's no electricity. So even if there's nothing flowing in this capacitor, right? This capacitor is discharged right now. It may actually have a voltage. I could charge it up and it might hold that voltage for a small amount of time. Now, it's very unlikely, just because of the way that capacitors are set up, that that would be the case. But you've probably all been familiar with batteries. Batteries have a voltage. And even if there's nothing hooked up to the battery at any given point, it has a voltage. It's kind of like a pressure. It's like how much of the, how much the electrons want to get out, right? So actually, I can go grab a multimeter. This is one of those things that you should have if you're interested in electronics. And I can set it to the voltage setting, and we can see that if I measure these two, there's pretty much nothing on there, which is about what I expected. But if I go grab a battery, even though the multimeter itself is using almost no power whatsoever, it's not really drawing any power from this, it can still measure that there is actually a voltage on this battery. And it looks like this one might be a little bit, oh no, 1.5 volts. So voltage is kind of like pressure. It exists whether or not anything is actually flowing. And to some extent, when water actually does start flowing, the pressure kind of goes down a little bit. Resistors, on the other hand, what are resistors? Well, resistors are kind of like, you have this pipe right here, and resistors are kind of like just a little thing that like narrows the pipe a little bit. You can imagine how that would resist water flow, right? Another way of looking at a resistor, another thing that you might look at this in this system is like, you have this apartment building. You have this apartment building, and you have this really big water pipe coming into the apartment building because they gotta, supply water for all of these people. But each one of these people is only going to get a tiny little water pipe going, off of that main, going to their apartment building, right? And you can imagine, for example, that what's going to happen is it's going to have to narrow down. And when it's going to narrow down, those people are going to get less water, which makes intuitive sense, because if you have this huge water main that makes a ton of has a ton of water, you probably don't want that coming out of your faucet every day. So you're going to narrow it down. Resistors can help us do that in electronics. Resistors can help us narrow down the amount of water that gets places. But what is the other thing this does? It also changes the pressure, right? Because if you have a bunch of water trying to get through a small space, the pressure is going to go up. Not exactly, you know, in a certain ratio. It probably does with water. I don't know what it is. But with voltage, it actually does. And then, so voltage is kind of like pressure. The other thing that you might have heard of is a thing called current, right? And current is kind of like the water flow. So current is kind of like the water flow, and it's affected by two different things, right? It's affected by the amount of water. It's affected by the water pressure, and it's affected by the amount of water that can get through places. So current is kind of affected by the voltage and the resistance. And there's actually a very specific ratio, but we're just going to talk about it like this to start with, right? So current is related to voltage plus resistance. Or not necessarily plus, but and resistance. Right? Current is related to voltage and resistance. What is the exact relationship? We'll talk about that in a second, but I just want to make sure that we go back and make sure that we understand all of this. So again, voltage is kind of like water pressure, right? If there's a bunch of water pressure, if you have a water tower that's really high up there, it's going to be really pushing on that water, and the water really wants to go somewhere. Resistance is kind of like narrowing a pipe, right? It might increase the pressure a little bit, you know, past that thing because more water is trying to get into the same space, but it's also going to reduce the overall amount of water that's going anywhere. And then when we, you know, come down to it, current is basically like the water that actually comes out of your, you know, it's kind of like the water that's actually coming out of your pipe. You can't really, if no water is flowing, there's not really any current flowing, right? If all of your taps are shut off, the water can still have pressure, but none of it is actually getting anywhere. And again, that's kind of similar to how it's going to work in electronics. Now, of course, this is not a perfect example. There are some differences, but this is more or less a way that we will start to think about things, at least at the basic level, and it'll get you about 90% of the way there. There are some places where it might not work perfectly, but it's generally a good way to look at it. Okay, so again, we said current, so the amount of water that's flowing, right? That water that comes out is related to, right? It's related to voltage, which is kind of like pressure, and resistance, which is kind of like narrow pipes. Now, current again is the water that's actually coming out of your faucet, right? And what if this is really important? Well, it's not voltage because that's just theoretical. You know, that's just something that could do work, but it's not doing any work on its own. And resistance, which is again related to that, but it's not really doing any work. Current is the thing that really does work. Current is the thing that makes light. Current is the thing that turns a motor. And you can think of it again, if current is kind of like water that's coming out, current is kind of like, you know, it could turn a water wheel, right? Current is the thing that's really actually doing some amount of, you know, actual work in the real world. Voltage and pressure are just kind of things that, voltage and resistance are just kind of things that theoretically exist. So current is what we generally care about. How are all of these things actually related, though? There's one equation, and I know that everyone hates equations. There's one equation that you really need to memorize in electronics. There's kind of two, but like this is the one that is really going to be useful. And it's this: V equals IR. And this is called Ohm's law. Right? Ohm's law, V equals IR, I is current. So what we're saying is voltage, which is in what? It's measured in volts, which you've probably heard, is equal to current which is measured in amps, times resistance, which is measured in ohms. You might also see it written as this. So this is really the only equation you're ever going to need to know, but we will use it later on to figure out, for example, how to light up an LED without completely destroying it. So that has been just a really, really great basic primer, and I know it's not immediately useful, but we're going to start to try to find ways to make it useful in just a second. So let's move on to the very next thing that we need to know, which is this thing. It's called a breadboard. This is what we're going to start doing some very basic electronics projects on, and in a second we'll actually end up using the Arduino as well with the breadboard to build some circuits that might be kind of cool. So before we can do that, we need to understand what is going on. So breadboard, you can kind of see it's got these two little lines down on each side. One of them is labeled plus, one of them is labeled minus. And then it's got a bunch of these holes, and some of the holes are right next to these lines, and some of the holes are over here. What is happening is that all of these are connected together, all the way down. And then each row, except for that end column, each row is connected together. So, for example, all of these, and I will try to highlight it as best as I can with my Sharpie, all of these will be connected together, and completely separately, this entire line will be connected together. So it's a little bit, you know, goes both ways. But each one of these rows is separately connected together, and they're not connected together otherwise. So if I were to take these things, which are called jumper wire, and I were to take one here and connect it here, well, that's not really useful because these two things are already connected together. On the other hand, if I were to connect it to this row down here, now what I've done is I've connected this row to everything in this row. That's going to be useful because what we're going to do with our breadboard is we're going to take this Arduino. This is a tiny Arduino. You can buy much bigger ones than these, but these tiny ones are cheap, and they fit inside of a breadboard. So I'm going to just go ahead, and you can actually kind of... This is a really cheap breadboard, so it's not made very well. But you can actually just sort of put it in, and it's a more or less a standard size. So it'll actually go in. And now what we have is every single one of these rows off to the side is actually connected to the to each one of these pins on the Arduino. So we can start to do things with it, which is really cool. So for example, one of the things that I'll want to do is that the Arduino has a voltage pin, and all of these are numbered. So it produces power by default. It's right here. So what I'll do is I will take something in that row and connect it up to here. So now we have our positive. Now, electricity has to flow back to a source. If it doesn't flow back to a source, it doesn't really exist. Voltage can't exist like that. Voltage is always relative to something else. We usually call that in electronics ground. You've probably seen it as minus, but what we usually do is we consider the minus, rather than being minus, we consider it to be 0, and everything else to be above it. It's not always the case, but that's usually the case. So we will see a pin that's labeled ground. We will go ahead and connect this up to this minus column. So now what we've done is we've connected the positive and negative, or the positive and 0 volt, up to each column that's relevant for the positive and 0 volt. So if I go ahead and I plug this into my computer, if I can find the right cord. No, I took it out earlier. Here it is. Nope, that's not it. Let's see if we can find the right cord here. There we go. So if I go ahead and plug this into my computer, what's going to happen is that the Arduino is nice enough to have a built-in power supply, and you can see that it lit up. And what we could, in theory, do now is use an LED. And I'm going to try to do that, but there's a really good chance that it's going to burn out, and we will see why in just a second. So let's see if I can find an LED capacitor. Here we go. LED. Perfect. I got 3 of them. So we have some LEDs. You've probably heard of LEDs from the light bulb. you know, most people have LED light bulbs now, or at least a lot of them. There are two leads. I believe one of them is a little bit longer than the other, and I believe that the one that's a little bit longer than the other goes in the negative or 0 side, and the other one goes in the positive side. And if that's wrong, nothing bad is going to happen. So let's just try it both ways. There we go. Okay, so I was wrong. The longer one goes in the positive side. So we can go ahead and put those in. You can see it lights up. Now the problem is, this actually gets really, really hot really quickly. And this is why I wanted to cover that thing called Ohm's Law. Because Arduinos, or sorry, LEDs have very, very low resistance. You can consider it to be, you know, it's not anywhere near 0, but like it's very low. And so we have V equals IR, right? And we can rewrite this as I, which again is current, is equal to R over V, or what is that? Let's actually derive this because I don't want to mess this up. Equals IR. So what we'll do is we will divide by R on both sides, and we get I equals V over R, right? That sounds more right. Okay. So current is equal to voltage over resistance. This is why this one equation is useful for absolutely everything in electronics, right? Because, again, these are kind of the very basics. So I is equal to V over R. We want to figure out what the current that's going through that light bulb is, because that's going to produce the light, but it's also going to produce a lot of heat. So the voltage is going to be 3.3 volts. What's the resistance? Well, the resistance is very, very low on an LED by default. It's very low. We're just going to assume that it's almost 0, and in fact, it's going to approach 0. Now, what happens to this equation as 0 gets smaller and smaller? So if it's 3.3 over 1, then that's 3.3 amps, which would be crazy. But that it's not even going to be that, right? Because it's going to be 3.3 over 0.1, right? And what is that? Well, that's going to be 33 amps. And then we're going to do 3.3 over 0.01. That's going to be 330 amps, right? I mean, it's obviously not quite this low, but the problem is that 330 amps is like ridiculous, right? 3 amps is ridiculous. An LED cannot handle that much current. For context, like amps is the thing that'll really like produce heat. It's current, right? Current is the thing that'll really produce heat in addition to light. And like even in wires, the resistance of wires will start to heat up once you're drawing a certain amount of current. So like you can't have this much current going through an LED. It's just going to burn out. It's just too much. And so what we need to do, because it's so low by default, because LEDs generally do not have a very high resistance at all, we actually need to do is we need to use a resistor to increase the, we need to use a resistor to increase the resistance. And I know this is a little bit hard to see. I'm going to do my best. But what we're going to do is we're going to connect one side of the LED, the positive side of the LED, which is, again, the longer side. We'll double check that, and it lights up. So the longer side of the LED is the positive rail, right there. And we're going to connect the negative side over to one of these rows. So we'll just go ahead, do my best. Connect the negative side over to one of these rows. So let me see if I can get a little bit closer view of that. Again, I apologize. But you can see it's one of these rows. Now what's happened is that every single thing in this same row, every single thing along here, all of these are all connected to this pin now. So what we want to do is we want to connect that pin to a resistor. So I'm going to go ahead and get a resistor. Now what resistor do we want? Well, we could figure this out depending on how much current we want our LED to use. We can use Ohm's law. I'm going to tell you right now that I'm just going to use a resistor that is 82 ohms. And the reason for that is because I'm pretty sure that it'll work fine, and we can do the math afterward and confirm. So what I'll do is I'll connect this resistor to one pin of this LED. Now remember, I could just touch it directly to the LED, but instead I'm going to touch it to this side of this leg. So now this is connected to this LED on the positive side. And then what I'm going to do is I'm going to connect that through to the negative side. You can see the LED lights up. Now the nice thing is this LED is a lot less bright than before, which means it's probably not going to burn out. And it's cold. Like it's not, I mean, it's not cold, it's really warm in here, but it's not burning my finger to have my finger on it, which means it's not really at risk of of burning out anytime soon. So what we've done is we've said, again, V equals IR, right? We divide by R. So I, current, right, current is equal to voltage over resistance. Well, our voltage is 3.3 volts. I know that because that's what the Arduino produces. The Arduino, whatever I give it, will turn it into 3.3 volts. It's nice like that. You can get other chips to do this for you. There are, I think the LM314 is what you would search for, if I'm not mistaken. That might be a different one. But LM2574 is a 5 voltage one. There are a bunch of different ones that you can get, but basically what it'll do is it'll take any voltage that you give into it and it'll give it to a certain voltage. And the Arduino has one of those built in, and theirs turns it into 3.3 volts. So that's how we know it's 3.3 volts. And it'll say it on there. It'll actually say 3V3. The resistance we now know is 82 ohms. Right? So what's our current? Well, it's 3.3 divided by 82, which is really small, right? Relatively small. And my computer has locked itself, so I can't quite do the math. Let's go to split screen here. You can see recursiveness, right? So we got 3.3 volts divided by 82 ohms, which is 3.3, which is very small, right? So 0.4 amps. That is not going to be a crazy amount like we were getting when we considered really low resistances before, because now we're actually putting a reasonable amount of resistance in this, which is cool. Now, how would we put a capacitor in this? Let's say, again, we were talking about capacitors. Well, capacitors can maintain pressure, right? Which is really cool. So what I can do with this capacitor, by the way, if they have a stripe like this on the negative side, you want to make sure you do not mess this up, because they can explode, which is not fun. But what a capacitor can do is, let's say that I were to disconnect this right now, right? I disconnect it from the power pin. The LED goes out really quickly. Capacitors can maintain water pressure a little bit. That's one of the things that they can do. So what I can do is I can put this capacitor, and let's find a slightly smaller one that's not polarized. So what I can do is I can put this capacitor here. I'll put the capacitor on this or this is ground, isn't it? Let's do it on the voltage pin. Let's do this. So we have this voltage right here. This is 3.3 volts. We'll put it down here into one of these rows. And then what we'll do is we'll put this capacitor here. And then we'll take another one of these jumper wires. And we will put this jumper wire up here. And we'll put the other side of the jumper wire down here on this capacitor, which is not working for some reason. Why is that not working? Is it this capacitor? Maybe. Let's see if we can get this working. Let's try a slightly bigger one, because that's not working. So this should be the positive side, this should be the negative side. Because I am completely hooking this up wrong. So capacitors are actually hooked up across voltage to ground. So what we do is we actually put it like this, because it's just maintaining water pressure. So this is what I was doing wrong, and I apologize. I'm not fully paying attention on the stream as much as I should be, because I'm trying to read at the same time. The chat. What's happening is that a water tower doesn't go like this, right? That's not what a water tower looks like. It doesn't go in and then come back out. All a water tower has to do is it just sits up here like this, right? And what it does is, and this has got some water in it, right? If the water pressure starts to go down, this thing will start adding more water to it. And the amount of water it'll add is relative to its height, relative to the pipe. So what we actually want to do is we want to do something similar here. But again, we can't just put it only on the positive side. We have to put it on the positive and the negative side as well, because electricity is always relative to something. So this is our ground up here. So we can actually just do it this way. This is our ground up here. We'll, again, match the negative stripe to the negative side, and we'll just put it right here. And you can see that absolutely nothing has changed, except that if I pull this out, well, that's not a very big capacitor, so let's see if we can get a bigger one. Let's see if we can make this work. It's not really noticeable here, I guess. Yeah, you can just barely see it happening there. Watch as this fades out slowly. So what it's doing is, as soon as we unplug it from positive power, this this LED would normally go out, right? Would normally go out. But the thing is, this capacitor is providing some extra pressure. So as soon as that, the pressure, the voltage starts to drop on this line, the capacitor will automatically go in and fill that back in. That's one of the things that a capacitor can do. The other thing that's really interesting about a capacitor is that it can prevent direct current from going through something. It can allow you to only pass alternating current, things that are going from positive to negative really quickly. And we're not really going to talk about that very much, but you will see it sometimes in that situation as well. I'm not going to explain too much about why. You can kind of figure it out if you wanted to. But that's one of the things that you'll most commonly see capacitors for, and particularly these really big ones. You'll see them for maintaining voltage in case there's some reason why it might decrease very slightly for a very short amount of time. So that's what we're talking about when we're talking about capacitors as well. Capacitors, resistors, again, we're not really going to get into inductors because you won't find them used very much except in a few specific cases that you're probably not going to learn as a beginner. So that's cool. We have now a circuit that has an LED lighting up. We don't actually need this capacitor, so I'm going to go ahead and just remove it for right now. We'll go ahead and put these over here for the moment. We have a circuit that's lighting it up, but it's not very exciting yet. This is not really doing anything particularly useful. So what we're going to do is we're going to make it do something a little bit more fun by actually programming the Arduino to do something. So what you'll see is, again, I've hooked this up. You can't really see this from here. Let me see if I can get in a little bit closer. I need to get a second webcam so that we can switch to close-ups when needed. Focus. There we go. So you can just barely see in there that we've got it hooked up right now to a pin that's labeled 3V3. Focus. Focus. It's not going to focus. I don't know what it is focused on, but nothing good. Okay. Well, that's webcams. So what we have it hooked up to right now is a pin labeled 3V3, and what that pin does again is it just reliably produces 3.3 volts relative to this ground pin, which is also labeled GND. What we're going to do instead is that this entire right-hand side of the Arduino, and some of the left-hand side as well, is labeled D. D0, D1, D2, and so on and so forth, all the way up to what looks like D12 on this one. And the exact amount will change depending on your specific thing. So what we're going to do is we're going to actually just connect this up to one of the D pins instead of the voltage pin. Let's just pick D4 at random. It can really be any pin. It doesn't really matter. Let's go ahead and get rid of this as well. So all of these little side pins, the ones that, again, doing this little drawing of the Arduino over here, dot, 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 dot. This is, D8, D7, D6, D5, and so on and so forth. These are what are called Gpio, which is something that you might see. And if, for example, someone was asking about Raspberry Pi, if, for example, you wanted to do this with a Raspberry Pi, you would want to search for Raspberry Pi Gpio pins, because that's what you're looking for. What does Gpio stand for? General Purpose In/out, which is a fancy way of saying that you can turn on or off these pins in software using this little chip that's on the Arduino that's controlling them. And by the way, on an Arduino, the chip that's controlling them is called an Atmel, or sorry, not, I don't actually know if it is made by Atmel. I think it is, but it's called an ATmega. ATmega, and the particular one will depend on exactly which Arduino you have. If I look really closely, I can see that this one is, yeah, the AT is short for Atmel. I can't quite read this. If you look really closely in the right light, you can actually read the writing on chips, and if you Google it, you can actually find out exactly what they do. But this is fundamentally what the Arduino is. When you see an Arduino, is an ATmega, which you can buy from a store like DigiKey, which is an online electronics parts store. You can buy these in a bunch of different options, a bunch of different what are called packages. So you can buy them that are like this, that are flat. You can buy ones that are not flat. I have one around here. Here it is. You can buy one that looks like this. And this will actually be the same chip, just in a different form factor, what's called a different package. But you can just buy these. This is about $1 for this thing. So if you look at the Arduino, you can actually figure out exactly what's on it. You've got this ATmega. You've got a crystal, which is literally a crystal that oscillates at a specific frequency because computers need clocks to keep track of time. You got a button. You got 4 LEDs, 4 resistors because you can't just have LEDs, a bunch of pins, and then I think on the underside of this there's a few more chips. There's some capacitors, some resistors, and probably a thing called an FTDI chip. But fundamentally, this ATmega is what we're actually going to be programming, and all the rest of the Arduino, all you're paying like $20 for or whatever it is fundamentally just for them putting it in a really nice package for you. So just to be clear, like there's nothing fancy about an Arduino. You can buy these chips. Obviously, this one is a little bit hard to work with because it's so tiny, but you can buy much bigger versions of them, ones that are this big. And I could actually just directly plug this in here. And all I would need is to reliably provide it 3.3 volts and give it a clock frequency, which you can do with a crystal. And I actually have a few of them. Let me see if I can pull one out. Crystal, which you can buy as well. So you could theoretically build an entire Arduino without using an Arduino yourself. You could just use the breadboard, which is cool. But Arduino is a nice package for testing things out. You can use it. I just don't. One of the things that kind of frustrates me is sometimes people only do Arduinos and then they're like, I'm done. Can't do anything else. And that's not true. It's actually not that hard to build your own thing that works like an Arduino. Just want to be clear about that. So we will go ahead and continue on. So what do I want to do? I want to switch over to my computer, I think. So which button is that? Split screen. Cool. So I've gone ahead and switched over to my computer, and what we're going to do is we are actually going to, and you can see it's going to feed back a little bit if I leave it there long enough. What we're going to do is we're going to switch for Arduino IDE. Now, if none of you have an Arduino, which is understandable, I did say that there were no prerequisites for this. That is totally fine. But in general, what you would do is you would download this Arduino IDE, and then you would run it. I'm using Linux, so this is going to be a little bit more difficult. I'll just make this bigger just so you can see what I'm doing. In Windows, you can more or less just run this. In Linux, it's a little bit more complicated because Linux is always a little bit more complicated. I don't think that this is working. So let me just /Arduino. There we go. Cool. And it's got this little splash screen. And there we go. We got this IDE. And I can make the font a little bit bigger. So by default, it says setup, put your setup code here, and loop, put your main code here. Setup, what we're going to want to do is, let's see. One of the major skills that you'll learn as a programmer is Googling things. It's like actually really important. And it doesn't really matter how good you get at programming because no one remembers everything in programming. So I'm going to just go ahead and Google Arduino pin setup. because what we need to do is we need to tell it, that's called pin mode. Pin mode. We need to tell it what our pin is going to be. So it's 4, pin 4, and I think it's output. And that looks right because it colored it. Now we want to do digital write 4, what is it? Digital write high. So we do high means turn on, low means turn off. We're not going to put anything in loop for right now. And then we're going to see if we can program this. I think that this is called an Arduino Mini. We'll try it. If it doesn't work, then that's why. So we'll go ahead and hit upload. And I do have to save it somewhere, so I'll save it here. Arduino calls these sketches. I don't know why. I would just call them code. Okay, we're going to have to bear with me for a second. This is a permissions error, so I'm just going to go ahead and fix this by running it as administrator. Root, if any of you are familiar with Linux. So what we're going to go ahead and do, we're going to do digital, or what, pin mode. We have it on pin 4, and it's an output. And we have digital write pin 4 high. Set the port. Does get board info work? Unknown board. We'll see. Save that again, upload it, and you can see our Arduino lit up very briefly. We'll see if this works. Uploading, and this is not the right board. So we'll try Arduino Mini, see if this works. That is not the right board. I don't actually remember what type of board this was because I bought this a long time ago. Let's try an Arduino Nano. Still nothing. Does it? Oh, nope, that worked. Gave me an error, but it worked. So you can see that our LED is turned on, right? That's not very exciting because we had our LED on before. But what we can do is in this, for example, this loop section, what we can do is this function, which if you're not familiar with programming, a function is a group of stuff that happens whenever you tell it to. And this particular function, everything inside of it, is going to happen every single second. I'm going to go ahead and close out of this because despite the fact that I've killed my notifications, it's still running. So this will happen every single, as quickly as possible, basically. This function is just going to keep running over and over. So what we'll do is we'll delay by, say, 1,000 milliseconds, which means sleep for a second. What we'll do is we'll turn it on, we'll sleep for a second, then we'll turn it off, which is to set it to low. Go ahead and run this. Oh, and we need to sleep for a second at the end, too. And now we have a blinking LED, which is super cool. What if we wanted to have, so this is what's called a digital port, which means it can only be 1 or 0. We could use these things called analog ports, which would allow us to change the voltage anywhere between 0 to 3.3 volts. So we could actually make it fade in and out. But do we have another way of making it fade in and out? Well, we do, right? So if we wanted to make it fade in and out, we could do it in the microprocessor. But again, a microprocessor, these little chips, are not anything mysterious. What they actually are is a bunch of individual transistors, resistors, and capacitors made very, very, very tiny with some very complex infrastructure. But what we can do is we can actually just do that ourselves by just adding in a capacitor. That is shorting out. Let's see if we can make this work. Having some difficulty actually getting it in. One of the leads of the capacitor is slightly longer than the other, which is not ideal. Is that going to work? Might not be on long enough to charge up the capacitor. So let's try putting it on for 3 seconds. I don't know why that's not working. It was working earlier. But that is okay. There might be something with this capacitor too. I don't know what happened to the one I was using. Oh, here's the one I was using earlier. Let's try this one again and see if we can get it working. One of the nice things about electronics is that realistically, like, you will have to do some debugging. So having something like a breadboard is actually very useful. And obviously, if you're designing something like a... Yeah, this one is working better. Obviously, if you're designing something like a... a little better. If you're designing something like a motherboard, you're not going to do the entire thing on a breadboard first. But if you're designing a more simple circuit and you are newer to programming, or if you're just not sure how something works, you can actually do it on a breadboard first and just see how well things are, are actually working, which is really cool because it means that you can test something out and just see if it works before you have to make a circuit board, which is not something that we're going to do today. But if you're interested, on Thursday, we'll actually go into make a very simple PCB circuit board. So that's more or less the basics. Now, obviously, turning on and off an LED is not super useful on its own, but have a little bit of an imagination here. So what if instead of an LED, this were a pump? Then I could use it to turn on and off, again, my watering system for my plants, which is something that I actually have. I am actually doing that. Or maybe this is a motor, and I could use it to open and close my blinds, which is something that I personally have actually done. Or we have a lot of these pins. So maybe you could use this to control multiple motors. And then you could have, for example, an electronic skateboard. Now the Arduino itself, the pins are really tiny, and it's not going to be able to turn on and off a really, really big motor because, again, like, it's the same as the LED. To turn a really big motor, you need a lot of current, and the Arduino is not going to be able to do that. It just can't. So instead, what we will actually do is we will use something called a transistor, which I'm not going to talk about too much, but it's kind of like a switch. Let me see if I can find some transistors. So this is called a this is a transistor. You've probably seen a little bit. This is a transistor, so you could use this to turn on and off things. This is what's called a Mosfet, and this is probably what you would actually use. But you could, by hooking things up with a Mosfet, which is something you can look at online, you could have this tiny little Arduino basically act as a light switch that's switching on and off a much higher voltage, or a much higher current, or both, to actually, drive a motor. And then you put a few of these in place, and what you have is a motor controller that could actually build like an electronic skateboard, or a remote-controlled car, or a robot. And you could do all of this with the Arduino, which is a really smart thing. So rather than just making it remote controlled, you can have it do things automatically, which is probably not exactly what you want for a skateboard, but might be what you want to do if you want to do a robot. We're not going to talk about too much about this, but again, transistor and Mosfet. There are some other types of things that are like Mosfets. These are kind of like a light switch, which we would draw like this, except they can be turned on and off electronically. So the computer controls a switch. They're not super complicated to use. If you're just starting out, honestly, I'd recommend actually starting with Mosfets because they work more like you'd expect when we say it's a switch. But they're super cool. This one in particular is it's what's called FQP30N. I can't fit this all in one line because I wrote too big. 30N06L. And you can buy these from Digikey, or you can also buy them from a cool place called SparkFun that'll sell you lots of things like breadboards really easily, as well, and starter kits, which I think you can also get on Digikey, but I think it's a little bit more confusing. So if you want to just try playing around with something a little bit more complicated, you could use this to control motors, which is really awesome. Because, again, the Arduino itself can't handle huge amounts of current flowing through it without, killing itself, basically. It's just, it can't. Current is harder to deal with on really tiny little pins like this. So you need something beefier like this to control it. Again, we're not going to talk more about that, though, because I just want to make this a very brief introduction to electronics and using a breadboard. So I'm going to wrap it up by just talking about what are some of the things that you should get if you want to start playing around with electronics. So what are the things that you should get? One, definitely get breadboards. I would recommend probably get at least 2 or 3, because if you're working on a project, you want to be able to leave it assembled. You don't want to have to take it apart every single time. These, by the way, probably $1 to $2 a piece. Not very expensive at all. Number 2, I'd probably recommend getting an Arduino. Probably an Arduino. You could get a full-size Arduino, but they're more expensive and they don't fit in the breadboards. I'd actually recommend getting an Arduino Mini as your first one, or I think this is called a Nano. I think you want the Arduino Nano. One of them doesn't have a built-in USB port. You want the one with the built-in USB port, which I think is the Nano. Or get something cooler, if I can find where I put it, something a little bit more useful. This one, it's actually called an ESP8266. It's a long name. 8266. You'll also see these called Node MCU. This is what you'd Google on Amazon. This is like an Arduino. It also slots into a breadboard, but this thing is $5, and it's got built-in Wi-Fi. So you can actually make internet-enabled things. And the other thing is, if you remember, let's just go ahead. Let's switch back to just this. So if you remember from earlier, though, like the code looked fairly complicated, right? So instead, what we want to do with this is that you can actually program the ESP8266 in a programming language called Lua, which some of you might be familiar with because it's what you can actually program a lot of video games in, which is super, super cool. It has the same concept. It's got the same digital pins. It's got those same analog pins, the ones that can output any voltage from 0 to 3.3 volts. But it uses this chip called the ESP8266 instead of the ATmega, which has this built-in Wi-Fi. The other cool thing about these, and you can kind of see it here, is it's actually got this module on top of this module. And it's kind of soldered on. And you can actually buy these things, the parts that are just soldered on, for even cheaper, for about $3 if you ever wanted to make a PCB out of a more complicated circuit without getting all the rest of it. But these things are great. I'd recommend these too. The only advantage you have of using a full-size Arduino or a Raspberry Pi is that you can get those things that are called shields that plug in on top of them. But if you're just getting started, you generally don't really need shields. It's usually a little bit better to, I think, to do things on breadboards, because shields sometimes make things a little bit easier. Certain things you can't really do very easily on a breadboard, like if you want to play an MP3, I think there's a shield for that. If you want to connect to Ethernet, I think there's a shield for that. But sometimes people get shields for really stupid things, like controlling motors, which, again, you can learn to do yourself. The thing about Arduinos and everything else, again, is that they're not that complicated, and they really charge you a lot more money than they sort of deserve for what they actually do, because you can build all of this stuff yourself on a breadboard, and it'll just be a little bit bigger. But you'll learn a lot more about how to do it, and you can actually build your own circuit boards from there that actually look professional like this as well, rather than just sort of hot gluing some things together. And then finally, so I'd get some of those. I'd probably get a set of capacitors. And a set of resistors. And what you'll get is you'll get basically, let's see if I can open this up. So these are actually inductors, but it's a little bit easier to see. You'll get a bunch of these that are on these little labeled pieces of tape. The tape is for automated assembly, but you're not going to use that. And you'll get a bunch of these in a bunch of different values, because you'll need a lot of different values in resistors. For something like an LED, like I said, we probably wanted, like, I think we said 62 or 82 ohms. For certain things, like what's called a pull-up or pull-down resistor that you'll use for transistors, those will be more like you know, 1,000 ohms or a kilo ohm or more. So I'd recommend getting a set of resistors and again a set of capacitors. Capacitors are less important. You'll probably use resistors a lot more. And again, both of these are probably like $5. Right? This thing is $5. These things are going to be $10 to $25. Again, if you have a Raspberry Pi, you can do it on a Raspberry Pi as well. I don't know the specifics of that, but you can program it in Python. The thing is, it's just super overcomplicated for turning on and off a light bulb. Then again, so is this. You can actually do it without an Arduino. That's probably what I'd recommend if you're just interested in getting introduced to this. Oh, the other thing that you need is a set of these jumper wires. And they're literally just things. They got 2 pins on both sides, and you use them to connect things on the breadboards. So we'll say jumper wires set. And I think I bought a set with a bunch of them for $3 on Amazon. So you can buy all of these from Amazon. You can buy all of them from DigiKey as well. /DigiKey. I think the only thing you can't get on DigiKey is the Arduinos or the ESP8266. If you get more into electronics, you'll eventually start using something like DigiKey anyway, so I totally recommend just trying it out. But basically for 25 bucks, you could probably get everything you need to start building circuits that actually do really complicated things, which is really cool. You can do a lot more than you probably think you can with just this stuff. Again, everything from turning on and off light bulbs to you know, you could automate your entire life just with more or less some of these things. Maybe the transistors or some Mosfets, which again we're not talking about too much, but some of those and like some motors, and you could probably automate almost everything in your life. That's what I'd recommend. And then the only other thing that you might eventually get interested in is soldering, which I think we'll talk a little bit about in the workshop on Friday. So one sec. Cool. So again, I only have one webcam, so I have to actually move it around. But again, this has been the Introduction to Electronics workshop. I am Tyler. I am the head of SR&D, and I wanted to thank all of you for being a part of this. If you have any questions, feel free to post them in the chat right now, or you can also join our chat, chat.srnd.org. If you're not part of CodeLabs and you just happen to stumble onto this on Twitch, it's just chat. And then basically the name SRND, which is our channel name, .org. And feel free to join. It's totally free. And basically the entire summer we're going to be making projects together. So if you want to do an electronics project and maybe before this you never thought you could, feel free to post in chat, ask some questions, and we are happy to help you out and see what we can make together over the summer. So again, any other questions you have, feel free to post them in the Twitch chat or there. This video will be archived on Twitch for as long as we can. It'll also be up on our YouTube channel if you want to go back and watch it later. And on Friday, we are going to do a different workshop about how to actually make your own circuit boards. So if you've ever wanted to make something that actually looks like this, right? We're going to talk about how to do that. And let me see if I can even pull up an example really quickly. So go ahead, go to split screen. And we can actually look at, can I make this any bigger? I kind of wish it could be a little bit bigger, but that's okay. We can actually, this is something that I've ordered, and we can actually make this circuit board on the computer and get a physical circuit board that we can assemble, which is super cool. So we are going to do that as well on Friday. And if you want to learn how to do that, you don't really need any electronics experience. All you need to do is remember those symbols that I taught you from earlier, which we'll cover again. And we'll actually design our own circuit board that will blink an LED, and then we'll go ahead and order it. So by the end of the workshop, you can spend basically $5 and have your own circuit board with your name on it and an LED working, which will be super cool. So that will be on Friday at, what time is that? At 4 p.m., so same time as today. I hope to see you there for that. And the only other thing I'll say, tomorrow at 12, we're going to do a workshop on hacking. So we'll actually talk about how to break into things, hopefully for good, because hopefully what we'll do is we'll learn to make our own web apps not super insecure. And again, I will continue to improve the quality of the stream each time we do it, so that should be a little bit better. So thank you all for joining us. Feel free to post any questions, and otherwise I will see you tomorrow or Friday, hopefully. Thanks.